Hello, third grade, and welcome to lesson 6-6. We're going to work on applying properties that we know and in order to find the area of irregular shapes. Now, when we say irregular shapes, we're talking about shapes that are not your standard shape, like a square or a rectangle. Let's go ahead and watch our video so you can understand what we're talking about.
How can you find the area of an irregular shape? Mr. Fox is covering a miniature golf course putting green with artificial grass. Each artificial grass square is 1 square foot. What is the area of the putting green that Mr. Fox needs to cover? Why can't you multiply the length by the width to find the area of the putting green?
Let's stop and think for this second. For this particular question, is our shape a whole shape? If it was a whole square that was 8 by 8, then we could just multiply the two sides and find our area. The problem though here is that a part of our shape is cut out. So we can see it's in the shape of a U, which means there's a part missing on the inside. So I can't just multiply 8 by 8 because then I'm counting this area that's not part of my shape.
You can't multiply the length by the width because the putting green is not a rectangle. It is missing a region in the middle. One way to find the area of this irregular shape is to draw the figure on grid paper. Then count the unit squares to find the area. The area of the putting green is 56 square feet. Why is counting unit squares not a good way to find the area of a large irregular shape?
Now, counting the squares is helpful, but if your shape is really large, counting each individual square will take you a really long time until you're able to find the area of your shape.
It takes too much time to count and keep track of all those unit squares. Another way to find the area of a large irregular shape is to think about smaller shapes that are part of the larger shape.
Look for relationships.
Divide the putting green into rectangles. Find the area of each rectangle. Then add the areas. Rectangle A is 4 by 3, so the area of rectangle A is 12 square feet. Rectangle B is 4 by 3, so the area of rectangle B is 12 square feet. Rectangle C is 4 by 8, so the area of rectangle C is 32 square feet. What is the total area of the putting green?
Select your answer.
Twelve plus 12 plus 32 is equal to 56. The area of the putting green is equal to 56 square feet. What is another way to divide this putting green into rectangles?
All right, so let's take a look at the try it section and see which other way we can split this. Now, I can take one of these big squares to cover, or these big rectangles to cover this region. And I can take another one to cover this region. And then I can take two of these smaller ones and put them together to cover this region. And I'm still going to get to 56. So you could have cut it straight down and made it into 3 rectangles like this if you wanted to. You didn't necessarily have to do it the way that you were doing it in the previous example. So there are lots of options and different ways that you can solve.
Now you know how to find the area of an irregular shape.
All right, let's get into our guided practice and our notes. So I'm going to walk you through that question one more time. How can you find the area of an irregular shape? You can break it into smaller shapes and then calculate the area of each, then add those partial areas. So this was our whole putting green, right? 8 feet on the bottom side, 8 feet across, 3 feet here, 4 feet down. This measured 2 feet, this measured another 4 feet, and then 3 feet. Now, if I wanted to cut this shape, I can cut it more than one way. If I want, I can cut it down this way. So then I would know that this is 3 feet, and this is 3 feet, and we know that this is 2 feet because it measures the same as this. Now we know if this is 4 feet, then whatever is left has to be the other half of the 8. So we know this side is also 4 feet, which makes this side 4 feet. And then I can calculate the area here. Now I can do 8 times 3 to find this one, right? Here's 8 feet times 3 feet. So I'll have this one as 8 times 3. This one is the same. There's also another 8 times 3. See, there's the 8 on this side. So 4 and 4 is 8. And then 3 over here. And that represents the area for this one. And then this one is going to be 4 feet by 2 feet. So this is 4 times 2, which equals 8. This is 24. This is 24. And this is 8. So then I would add these together. And I can do 8 times 3 equals 24. Another 8 times 3 equals 24. And then the middle, 4 times 2 equals 8. Now, if I add those all together, 4 and 4 and 8, 8 and 8 is 16, put the 6, carry the 1, 2, 4, 5. I still get to 56, so the area is still 56 squared feet. Now, if I wanted to cut it the other way, the way they had it in the picture, I can do that as well. So I can cut it into the shape that they were talking about, where I cut it across. Now I know this is 4 feet, and this is 4 feet, and this is 3 feet. So this becomes over here a 4 times 3 rectangle. This side over here was also a 4 times 3 rectangle. And that made this side over here a 4 times 8 rectangle. Now I'm going to do the same thing that I was doing earlier, and I can cut it the way that they had it in the video. So again, that side, when you cut it in half, if this is 4 feet and we know the full length of this side is 8 feet, that means 4 and the rest of it is 4. So this became 4 by 3 is 12, 4 by 3 is 12, and then 4 by 8 is 32. We added those together and we still got to our area of 56. So whether you had cut your shape this way or you cut your shape this way, either way, you got to your answer of 56 square feet. Now I'm giving you guys another shape down here that we're going to work out together. This shape is also an irregular shape, right? It's not normal looking. It doesn't follow the rules of squares and rectangles where you can just multiply the sides and get an easy answer. What we're going to have to do for this shape is we're going to have to cut this one as well. So I'm going to grab a marker and we're going to work on cutting it. Now we know this side from here to here is 3. Okay, so if I cut right here, I know this is a 1 times 1. And over here again, here to here is 3. And I know this side is 1, so that means this side up here is also 1. So this is a 1 times 1. So if this is 5 here and 1 here, altogether this is going to be 6. So 5 units plus that 1 unit is going to be 6. So 3 times 6 is going to be my middle. So we know 1 times 1 is equal to 1, another 1 times 1 is equal to 1, and 6 times 3 or 3 times 6 is equal to 18. I'm going to have 1 times 1 equals 1, plus another 1 times 1 equals 1, and 3 times 6 equals 18. Now I'm going to add those partial products, those partial areas together to find my answer. So 1 plus 1 plus 8 is 10. Put my 0 there and carry my 1. 1 plus 1 over here is 2. So this is 20 square units. Now, if I'm not sure, I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what I did was I took this part off and I took this part off to calculate the middle section. I calculated each one of these on their own. So I know if this from here to here was 5 and then I had another one, I knew that this whole area was actually 6. So you have to make sure you're paying attention to all of the units and where they're telling you the length of those units are. Okay, so let's jump into our guided practice. Explain why you can find the area of the putting green using different rectangles. So that same shape that we were working with on the beginning, I drew it in a smaller version over here. So the first time we cut it was we cut it across and we multiplied the different sections to find the area and put them together. This way was the way that we did it like this, where I cut it into 3 long rectangles like this. We found the area of each part, put it together, and we saw that our area stayed the same. So even if you cut the area differently, the total area stays the same. So if you're cutting the shape across, you're cutting it up and down, you're not adding anything extra and you're not taking anything away that you already had. All you're doing is counting it a little bit differently, but you're still counting the exact same amount. For number 2, explain what operation you use to find the total area of the small rectangles. Well, I need to add the area of the small rectangles once I find them in order to find the total area. Now for number 3 and number 4, they gave us some rectangles and they asked us to cut them and find the area. Now you did not need to cut them this particular way. I just happened to cut them this way. So this rectangle measured 5 on this side, 5 on this side, 2 over here, 3 over here, and then this whole long side over here was 5. So if this was 2, then this area would also be 3, because 2 plus the other 3 would get us up to the 5 where we were. So this was a 5 by 2 rectangle, and this was a 2 by 3 rectangle. So I multiplied 5 by 2 to find 10, and 2 times 3 to find 6. I added those partial areas together, and my total was 16 square inches for this particular shape. For number 4, I had a measurement of 9 on this side, 6 on this side, 3 on this side, and 4 on this side. Now I cut it across right here. So this became a 3 by 4 rectangle, and this became a 6 by 6 square. So I separated the 9 into 3 and 6 more. 3 plus 6 gave me 9. Since this side was 3, it made it easy to just cut it across, so I knew this side would also be 3. I subtracted that 3 from the 9 to figure out that this was 6. So 3 times 4 gave me 12. 6 times 6 gave me 36. I added the 12 plus the 36 to figure out my total area here was 36 square centimeters. So when you're cutting a shape, cut it in a way that's easy for you. There's no particular right way or wrong way to cut it, just like with this one. You could have gone either way and you still would have gotten the correct answer. Just find a way that works easily for you and follow it through to find your answer. If you have any questions, let me know. Otherwise, I hope you have a great day. Take care. Bye-bye.